welcome. Here we are. We'll try again to see how this goes. Howdy. Oh man. Hello. To see how this goes. All right, pretty good. So yeah, not bad. First 20 seconds figuring out how to get the live stream going. Okay, remove all occurrences of a substring given two strings s and part. Oh, right. I went over this the other day. Yeah, I'm going to use the basic approach. Just I could use a modified KMP algorithm, I think, for this, but I'm not going to do that. That's not necessary. Yeah. Shoot. I'm just going to turn off the microphone sneeze, but I thought of it too late, and then I stopped myself. I was going to stop myself from sneezing to hit the button, but then it was too late, so I ended up just stopping myself from sneezing. But I might sneeze again. All right. So, we'll say you can actually do it this way. I think it's index 0, index equals s dot substring part. It's not equal to s dot or string and position. Then we say s equals might be able to do it this way. It kind of makes a little more sense. Then s equals basically erase index and part dot size, something like this. I'm not sure if this will this might not compile. I don't remember the syntax for all that. I don't really know it offhand. I'll just start off with this. I wasn't sure what to start that value with. Okay, no while conversion from string. I guess it's going to be find more accurately. Find the index. Oh, it works. Okay. So erase and find both work on the substrings. This may or may not be correct. Yep, it's correct. Okay. Yeah, it's efficient. Yeah, the test cases are really small. It's kind of a super easy one because the test cases are so small. But it could be, like I said, you could do it in linear time, I think, with a modified KMP algorithm, but I'm not going to do that here. We're going to just keep going. There's no real reason to do that. Let's see. Okay. Oh, I also forgot to change the title of the stream. We're gonna do 4 hours today. So let's do how many hours do I have? How much time do I have? Almost 5 minutes now. Okay. Yeah, we're gonna do 4 hours. Generate a string with characters that have odd counts. Okay. Get integer n, return a string with n characters such that each character in string occurs an odd number of times. Turn string must only contain only lowercase English letters that are multiple vowels. Turn any of them. Oh, okay. Odd number of times. With n characters. I mean, could I just do one of each? Can I just do a n times? Huh. Think this works? If it's odd, then we do all A's. If it's even, then we do all A's and one B. Okay. I'm just going to go for it. Is that what they're looking for? Okay. There's not much to say about that. There's not a lot to say there. Okay. Minimum string length after balanced removals. String S consisting only of the characters A and B. You're allowed to repeatedly remove any substring with a number of A. A characters is equal to the number of B characters. After each removal, the remaining parts of the string are concatenated together without gaps. Return an integer denoting the minimum possible length of the string after performing any number of such operations. So, only A and B. Remove any substring where remove the number of A characters equal to the number of B characters. Remaining parts of the string are concatenated together without gaps. Minimum possible length of the string after performing any number of such operations. Interesting. So I could remove both here. I cannot remove any there. And here I can only remove these two. 100,000. I'm not sure about the answer to this one, actually. This is a little bit subtle because the question is, can I remove these substrings? Do I have to remove them in a certain order? Is the main question here. If I can remove them in any order, then I can do this in linear time quickly by just removing them one by one. But I'm not sure that I can. I could alternatively just use a stack, but yeah, I could use a stack-based solution. That's probably fine. Could go with that one. Okay, so we'll do int result 0. You do it that way. Const jar chns return result. So plus equals ch equals a minus equals. So we'll add a and subtract b. Just take the absolute value of the result. Because it could be very negative or very positive. It's probably correct. Not really sure. I mean, in this case, I could just count A's and B's, take the difference. I don't know. This is basically under the assumption that I'm not really sure about this. I think it works. I think because it's A or B, like there aren't too many ways to mess this up. Basically, every time you see a B, you pair it with an A and remove it, and you end up with just a long list of A's. And then the same thing if you do B's instead of A's. It's negative, but it's the same concept, just in the other direction. I think it works. It's not the most obvious thing, but I think it's correct. Could make a very B-heavy string. Seems to be okay. Thinking if there's a more clever way to do this. Count the difference between the A's and B's. Yeah, that's right. Okay. 5 milliseconds though. I mean, I don't know if there is a more clever way to do this. This seems about it. Okay, that's fine. Keep going. How are we doing on time? 12 minutes. Okay. Let me see. Yeah, getting some buffering. It's not the best, but it's okay. Optimal partition of string. Given a string S, partition the string into one or more substrings, such that the characters in each substring are unique. That is, no letter appears in a single substring more than once. Return the minimum number of substrings in each such a partition. Note that each character should belong to exactly one substring in a partition. Okay. Characters in each substring are unique. No letter appears in a single substring more than once. Interesting. Could use a Boolean array, move left to right, and as soon as I see a new 1, 2, 3, 4, 1, 2, 3, 4. As soon as I see it, I could basically a greedy algorithm left to right, I think works. Yeah, because as soon as you see a repeated character, that means you can't extend the substring, that particular substring, further than that. 1, 2, 3, 4. Yeah. Okay. I think greedy works here. Not the easiest thing to prove, but I think it works. Okay. Go for it. So greedy can just do bool array of scene 26 0 for const jar chs. The minimum number of substrings. We don't actually need the substrings themselves, just need the number. Okay. Maybe it's easier to do the following. Yeah, I mean, okay, let's do it like this. Size 0 is less than s dot size. Increment I, and I can say maybe previous is good too. And we'll just say previous equals I. Come back to that in a moment. So the character is const char ch equals s of I. Scene of ch minus a equals true. So we say if scene of ch minus a, then we're going to do some things. Actually, no, this is still going to set this. Actually, that's fine. I think I can get away with it without an else statement. Okay. So if we've already seen it, then a couple things are going to happen. Number one, we're going to do some processing, and then we're going to actually reset all of the previous to I, less than I values. And here we also reset previous to I, update previous to I, and we're going to say scene of s of j minus a, character const char, current char, just some alpha, I'm not sure what to call this, current. So this is instead of filling the entire array each time this occurs 26 times with emptying the array, we're gonna or the buffer rather, we're gonna do it character by character backwards. Basically, go over the characters we just saw. Go over them again. And I think we increment the count. Actually, I think it's that simple. The alternative is to just fill the scene array with zeros. This is a little bit more complex, but possibly a little bit more efficient. Might be kind of an early optimization that's unnecessary, but something like this could work, I think. Okay, expression. Oh, I don't have my typos in there. In theory, this works. Let's see what happens wrong. Okay, we got 3, should be 4. There is. I think I have to add 1 at the end. I think I just have to add 1 at the end, actually. Just plain old start with 1, because the last one literally the last substring just isn't going to get counted the way that I have it written, and it's always going to be there, so I just start with 1. I'm going to go for it. It's probably correct. I could be wrong, but maybe. I think it's okay. Yeah, not bad. Okay. Slow though. Might need to optimize a bit. Okay. A lot of buffering, unfortunately. All right, we're looking at 20 minutes in. Okay. Try one more time. If it's if it's too slow, I'm gonna put this into the system here. Hello. Hello. Try one more time. Should be faster than this. This is actually kind of slow. Whatever's going on there is having a hard time, huh? Greedy approach. Yeah, it's slow. For some reason, it's slow. The alternative would be could make this thread local. I don't know if that matters. I don't think so. Don't think that matters. Yeah, I don't know why I'm getting 3 milliseconds instead of 0. Yes, can be significantly optimized. Okay. Bit mask optimization. Okay. Huh. Oh. Last index where each character appeared. Start index of the current substring. Character's last seen index is greater equal to start. Duplicate exists in the current partition. Oh, there's 100%. Okay. So there's 100%, but this could be faster. Start index of the current substring. Character's last seen index is greater equal to start. Duplicate exists in the current partition. Increment the count and update start to the current index. No need to clear data structure, simply update the start boundary. Oh, interesting. Track the last index where each character appeared. Okay. Huh. Oh, I don't need to clear the data structure. Oh, it's constant space approach. Yeah. Okay. Oh, that's a little bit easier. That is faster. All right. I like the bitwise approach though. I like the bitwise approach. Should keep that in mind in the future. If I need a Boolean array for characters, I can just use a bitwise approach. So it's going to be seen and it shifted to the character index. Increment the result. And then just set scene equal to 0. Huh. How about that one? How about that one? Too many parentheses. That's even better. That's even better. I like that one the most. I think that's probably the best. There we go. That's 0 milliseconds. That's very fast. This also doesn't need the I value either. This can just be const char ch. All right, how we doing here? Still a lot of buffering, but not terrible. Some reason still gives me 2 milliseconds though. All right, great. So very interesting. Yeah, that's definitely better. I like that better. I'll keep that in mind in the future. Cool, cool, not bad. All right, n unique integers sum up to 0. Given an integer n, return any array containing n unique integers such that they add up to 0. Any array containing n unique integers. The easiest one is just go -1, +1, -1, +1. If it's odd, then you just add a 0. Yeah. Okay. So, sure. Stood vector int result. Reserve n for, actually, you can even, yeah, I'll just reserve that. That's fine. I equals 1, I is less than or equal to n divided by 2. So if n is 4, I would do 1, 2. Yeah, that's correct. If it's 5, I would do 1, 2 as well. Push back. I and negative I. And then if it's odd, 0. Assuming I can put 0 in there. This works, right? Let's do 1,000. 1,000, 100, 500, 499. Let's try these things, see how it goes. It's a pretty straightforward question, I think. Yeah, okay. How are we doing on time? I think it's been 29 minutes, almost half an hour. 0 milliseconds is good. Pretty good. Pretty good. All right. Select data. Here we go. Okay, pandas. All right. Get some variety. Write a solution to select the name and age of the student with student ID equals 101. The result format is in the following example. Student ID, get the name and age. Okay. Example 1, Ulysses, name, age. Okay. I'm not very familiar with Pandas syntax, so I would need to tinker with this a little bit. We're gonna do STS as the students. PD data frame. All right, let's try this. Querying data frames. Pandas data frames. Syntax. Like to get a row matches a particular condition, and I want to exclude parts of that row. Like, I understand SQL syntax a little bit better. Spent quite a bit of time on learning SQL syntax, but Pandas syntax is a little bit different. Boolean indexing for the row, column selection, exclude parts. So, location most efficient. Filter rows and select drop columns in a single step. Row condition ID is 101. How did they know? How did they know? Oh gosh. That's almost creepy, huh? How'd you know? How did you know? It's looking for ID 101. I'm being watched, man. I'm being watched. Just a hypo. I don't believe you. It's the government, man. Being watched. I'm being watched. It's just a hypothetical. That's what they all say. Oh, that's funny. What are the odds of that? It feels like the odds of that are so low. Get the exact number and ID that I'm looking for. I don't know. Maybe it's trained on this exact example. I don't know. I don't know. I don't know, man. I don't know. Who knows? Get a row matching a condition while excluding specific columns. You can combine Boolean indexing for the row with column selection, exclude parts. Okay, use .lock, most efficient. This method allows you to filter rows and select drop columns in a single step. Row condition, df columns is in. What is this? So, data frame. So you can create a data frame like this, which is good to know. Filter row where ID is 101, exclude password column. Okay. What is the .lock syntax? What does .lock stand for? Some kind of an abbreviation. So this is the condition, and then this syntax is kind of weird. It's a negation .columns .is in. What's going on? The df columns is in password syntax. Let's read some of this here. Interesting. So that I can use chaining, query, and drop. More readable for complex conditions. Query condition, drop, columns to exclude. That's maybe easier. Let's do that. I like that one better. Query, drop. That one a lot better. Okay, so we're going to return STS query. Condition is ID or STS student ID. It's equal to 101 dot drop columns student ID. How about that? Let's see if that compiles, that executes. That's what they're looking for. Excluding a single column. Simple inequality check on the columns attribute. df.columns not equal to columns excluded. That's maybe a little bit easier. Okay. Hypothetical example. Even gives me the dice to let me know it just guessed. But the odds of that are like 0. The odds of all the numbers you could pick from to exactly pick 101 is just, anyway. I guess it's not 0. I guess it's the most likely choice somehow. Sample data set, arbitrary IDs, demonstrate the syntax, don't have access to actual data files, specific values. I don't believe you. Truly do not have access. I don't believe it. I don't believe it. Common convention use generic numbers like 101 and 42. Okay. So it was really a toss-up. So it was really just a 50-50 chance between 101 and 42, wasn't it? That is a much higher chance. Not quite. It wasn't a random 50-50. Generated the number. Let's see. Standard, famous, more common. No. You don't understand. No. The probability that you pick is this 101 of all numbers where you generated. Simple. If it's not 50-50, 142, then maybe it's just 100% going to be 101 each time. It's definitely not 100%, nor is it a random guess. It's a deliberate convention, not a random selection of fixed AI rule. Okay. Decades. It's bled into general culture. Standard placeholder. It's just an example. Is it always 101? Might use 42, 123, 999, 555. It's a stylistic choice. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Right. But for database questions, it's good. It's good. I don't believe it. I don't believe it. Oh, okay. All right. Give you a break. All right. Let's see. What was I even doing? Syntax. What is? That is pretty crazy though. The odds of that. It's just seem suspiciously unusual. Okay. Location, specifically label-based location. It is a pandas property used to access a group of rows and columns by labels or a Boolean array. So location, label-based location, row selector, column selector. Can be a label, a list of labels, a slice. Interesting. Slice or Boolean condition. Wow. Interesting. Column selector, similar to rows, but targets column labels. Huh. Targets column labels. Oh, okay. Python standard slicing .lock slices are inclusive of the endpoint, includes row 5. Columns is in. Okay, so that's a really peculiar syntax. They have selectors. Okay. Wow. It has code in the selector. Is it Python code in the selector? Selector object for the lock syntax is code in it. Can I perform a pandas injection as opposed to an SQL injection, which runs code on the database? Wasn't originally intended. Is this a security hole or flaw? It's a vulnerability. Potential security vulnerability. Why, hello? Why, hello? Why, hello there. Can I get into your database? Can I run code in your database? I might want to take a look around. Yeah, I don't know if that's a great design choice. I don't know if I should be using that syntax, quite frankly. I don't know. Maybe I'm wrong, I don't know. Boolean mask. Used to dynamically select columns by excluding specific ones. Here's the step-by-step logic. Retrieves an index object containing all column names in the data frame. Okay. Dot is in checks each column name against the list password, returns a Boolean array. True means the column is in the list. Okay. Huh. Excuse me. Wow, there's a lot going on there, huh? The tilde operator, this is the bitwise not operator, inverts the Boolean values, become false and false becomes true. Select everything except password. Passed as the column selector keeps only the columns where the mask is true. Oh, so it's a Boolean mask that's really an array, or a list of Boolean values. And so you get df columns gives you a list of columns. Then the dot is in converts that to a is there a dot is not in function method function? Do I call it function or method? Method? I think it's method. Objects, it's methods. When it's not an object, it's function. Oh, bingo. Oh my goodness. I was like, that smells like bad design. Oh, it is. Wow. Gee. Oh my gosh. Of course it is. Immediately, it's like, yep, you guessed it, bud. Arbitrary code execution. Yes. The answer to your question is yes. Oh my gosh. I can't believe it's too fun. I, I don't know, dude. I don't know what to say. It's unbelievable. Too good at this game, dude. I'm too good at this game. All right. Explain about C++. What's up, Hazan? Hazan, welcome, howdy. It's the best, man. That's all I gotta say about C++. C++, C++ is the best. No, I could explain more about C++, but it's definitely C++ is kind of involved. Oh, so the syntax is wrong. Uh-oh. Come back to that. We'll fix it. I do want to read more about this, though. Oh my gosh, man. That's so funny. That's too funny. Did I ask about something else up here? Oh, yeah. So I want to understand what's going on here. All right. So that's cool. So that's one way of doing it. Maybe not the best syntax, but because of the security vulnerabilities, but sure. Okay, what else? Yeah, it's me jabbering with the jibber jabbering with the AI here. I'll pick a promise next time not to make you feel like you're being watched by the government. Crushing that pandas code. All right, here's a real security vulnerability. Immediately, I'm like, this and that, like you can't do that. Don't do that. Don't do that. Even gives me how to attack it. All right, that's great. This picture. Dot not in. No. Okay. Bitwise operator. That's fine. How it works. Loading series. Got it. Got it. Got it. Using query, not in keyword inside query. The query syntax definitely exposes other security vulnerabilities, doesn't it? Okay. Status not in. Oh, I see. Let's try. Let's actually go back a couple things. Let's do this. So we're gonna copy pasta. Oh no. Copy pasta. Because this is wrong. And it's gonna give me the right, it'll give me a variation or a difference, but let's try the dot lock. I think I'm just gonna refuse these pandas. Too many security holes. Too many security vulnerabilities, man. It's crazy. That's crazy. That's crazy. df dot columns dot is in the list is student ID. It's not gonna be that one, and then it's gonna be df of student ID equals 101. All right. Oh, it's not a data for its STS. Hence why I changed it from students to STS before. Location indexer takes from 1 to 2 positional arguments, but 3 were given. Oh, getting some errors here. Safe, recommended, query, immediately, Boolean series. Okay, that's cool. Equivalent, simpler syntax. Lock, drop, maybe better. Direct indexing. Oh, interesting. Safe and concise. Let's do lock and drop. I like that better. Or no, excuse me. We'll do directly drop. Let's try that. Apparently that's another syntax that works here. I'm gonna go for it. What's up, chat? How to learn Python to make fundamentals strong and can't solve problems. What's up, Mustafa? How you doing? Well, welcome, howdy. You gotta practice, man. You gotta read. Lots of reading. You gotta practice. You gotta practice. Syntax error, of course, square brackets. Oh, okay. I was wondering. I was like, it's giving me a hard time, man. It's giving me a hard time. Why does it give me such a hard time? All right. So this one. Okay, hold on. Let's go back. This is supposed to be correct. All right, let's try it. Do each one of these. I like the direct indexing. That's pretty good. Okay, so that works now. And then we're going to try query and drop. Okay. What was wrong with the query code and the drop code? What was wrong? Yeah. Let's try this one. So query, and drop. Yeah. This one gave me an error. If I pass the string, okay. Yeah, no, that's even worse, actually. It's an even worse security vulnerability, I think, an arbitrary string that gets converted to code. It is not iterable, of course. We got int is not iterable. Oh, okay. Got it. How about that one? And it works. Okay. Oh, let's see. Would not, it's brackets, because the string is directly going to check student ID property against 101. This is crazy, man. This is thinking about like the security vulnerabilities involved, and I'm like, this is nuts. What's up, chat? Okay. Not standard Python code, string expression. So one of them gives you access to domains, to two different domain-specific languages. One of them's the string expressions, and the other one's the selector expressions. Oh man! Wow! Wow! Okay. Let's look at those some security vulnerabilities. We gotta be good, well-rounded programmers. Need to know how to break things and not be broken. Break things and not be broken. Not a naughty. Okay, got it. There is no not in. Query is a query. Yes, absolutely. Oh my gosh, the AI's response is so funny. Your syntax definitely exposes other security vulnerabilities, doesn't it? Yes, absolutely. Oh my gosh. Also, I appreciate how arbitrary code execution is the acronym is ACE. You literally get aced by the hackers. Aced. Your system has been aced. One shot aced. That's brutal. Brutal. Alright, let's look at the other security vulnerabilities. Gotta be well-rounded programmers. Well-rounded. Where did I ask about it? No, not this one. I went too far. I should have just Control SCV. Yeah, okay. Pandas injection is a real security vulnerability. That lock itself is generally safe when used with Boolean arrays. The related .query method and eval methods, eval functions in pandas are highly susceptible to code injection. They process untrusted user. Okay, so it's actually the lock is generally safe. Okay, that's good. Core issue is that methods like df.query and df.eval effectively run Python's eval on the input string. If an attacker can control that string, they can execute arbitrary Python code on your server. Its severity vulnerability was officially disclosed in March 2020. Oh my gosh. Okay. Versions. So, execute arbitrary commands by crafting malicious queries and using the Python engine. Official stance. Pandas developers explicitly state in their security policy that do not consider this a library vulnerability to be fixed in the traditional sense. Treat these as inherently unsafe for untrusted input analogous to Python's built-in eval. Documentation now carries explicit warnings. Okay, it's lock safe. Boolean array is safe. String.lock with a pre-constructed Boolean array is generally safe from code injection. The comparison happens in standard Python C code, not by evaluating string expression. Okay, so that's pretty good. String expressions. This is the one I was concerned about. Unsafe. If you... Oh, no, don't do that. If you dynamically construct a string to pass into a mechanism that evaluates it, you are vulnerable. Yeah, that's what I was thinking. Example of an attack, which is really hard to avoid when you have a dynamic. If you have systems that are actually doing things, you're going to have user inputs all over the place, and there's all kinds of cascading kind of ways that user inputs interact with each other. It's not really possible to avoid any code you write. It's very difficult to avoid user input getting in there somewhere. So you really do need to have pretty strong guarantees on how user input's going to be accepted and processed and so on. Broadly speaking, you should basically just never use things like this, like string expressions and like basically DSLs that users can potentially manipulate. You pretty much just avoid completely, unless it like doesn't matter if they totally break it. Example of an attack. If your code looks like this, do not do this with user input. User condition, request to arc div filter, result div query, user condition. Danger! Do not do this with user input. Yeah. It's a bad idea. Attacker could supply a filter like compat OS system or just went right for the jugular with that one, huh? Just straight up, like, we're gonna destroy your entire system. Holy smokes. Not even like they're gonna install spyware or something and just get rid of everything. Oh, okay. Well, there you go. It's one way of doing things. So it's one option. Gosh, man, that's wild. Okay. Well, there you go. Whew. AI doesn't mess around, man. You don't get a fight with the AI. It's just gonna everything's gone, and it's gone, and it's gone. It's spyware. We're going right for just get rid of just toss everything. Okay. How to prevent it. Avoid query with user input and never pass all user input directly. You basically should just never use these. Forget even passing user input, because anything you're doing is going to be influenced or affected by user input in some way. Down the line, the user's going to have a say on what goes in there. Use Boolean indexing, and stick to standard Boolean indexing without lock, which does not evaluate strings as code. It's using Boolean indexing. Validate and sanitize if you must. Use dynamic filtering, strictly validated input types, IDs or integers, whitelist allowed, columns operators. Update pandas, ensure you are running the latest version of pandas to benefit from documentation warnings and mitigations. Documentation warnings. I don't read the documentation, I just read chat. You are my documentation. Well, I guess as long as it... I probably shouldn't say that publicly. I probably shouldn't say that publicly. Stop reading documentation long ago. Just rely on memory, vibes, and chat. Oh boy. Definitely not a great statement to make publicly. Though the fundamental risk of eval remains. Don't use that. Just don't use those things, man. All right, and then what about the other vulnerabilities? Yeah, I think actually it kind of just repeated what it said before, that you can ace the system with eval. By design risky. Okay. Use Python at your own risk, man. Oh shit! No, stop it! No. It's a misclick. Sort of a misclick. Yeah. Okay. What else is there to say here? This, in my opinion, is a weak measure. While you can do this, it's not a bad idea. It's not a great idea. Like, this gives you a false sense of security, in my opinion. Like I said, you can user input. Users always eventually have a way of influencing your how your system works. So even with whitelists and stuff, it can still get pretty wonky. Yeah, even just trying to like sanitize it. You should sanitize your inputs regardless of what you're doing, but even with input sanitization, like things like this that can run arbitrary code is just super dangerous. All right, that's interesting. So, okay. This is the we went over before. Let's see what is wrong. What was wrong? Oh yeah. Yeah, so there's some syntax stuff that I just don't use pandas that much. Some of these things are mistakes. I wouldn't even say mistakes. I mean, I'm just straight up learning the syntax at this point. I don't actually know some of the syntax. It's actually new to me. It's point blank new to me. Like this one, I wouldn't know that the query is done the way that's done. All right. Anything else here to read? I think we got it. Okay, we can move on now. Learning. Everybody likes to learn, don't they? Design browser history. Okay, you have a browser, all right, of one tab where you start on the home page. You can visit another URL, get back in the history number of steps, or move forward in the history number of steps. Implement the browser history class. String homepage initializes the object of the home page of the browser. Visits URL from the current page. It clears up all the forward history. Okay, I'm not sure what that means, forward history. Back, move steps back in history. Oh, I see. Okay, so if you went back a few steps and then you went somewhere else, it'll clear all this, all that other history. If you can only return X steps in the history and steps greater than X, you will return only X steps. Return the current URL after moving back in history at most steps. So this is like a queue or a stack or something like that. Excuse me. String forward, move steps forward in history. If you can only forward X steps in the history, and steps greater than X, you will forward only X steps. Return the current URL after forwarding history of most X steps. I'm wondering if a double-ended queue would work here well, or if these are kind of small, so it's not that big of a deal. Excuse me. Hmm. Thing I'm concerned about here is it's almost like a sliding window type of deal where the more pages you visit, it like fills up the buffer, and then once the buffer gets full, it starts dropping the first elements and starts kind of shifting over. But also, you're supposed to be able to go backwards too, which modifies the buffer, removes those from the buffer. It'd be kind of, I was thinking a vector works okay, like a stack works okay, where you add elements, and then when you go back, you pop those elements, and then, although not necessarily popping the elements, you're just moving your position, and then you can always go back into the buffer. So you can move around in the buffer. So it's like a double-ended, it's like a queue buffer type of thing, double-ended queue buffer that you can also drop parts of it, and you can also navigate inside the buffer. That's kind of interesting. I hadn't thought about that. That's a pretty interesting setup here. So, okay. Let's think about this. What would be a good data structure for this? I think, how many steps can I go for? How much history can I have? Start with that. Steps 1 to 100. So visit back and forward. You can visit another URL, get back in the history number of steps, or move forward in the history number of steps. Does that mean I keep all of the history? Visiting a URL from the current page clears up all the forward history. Okay, so I don't need to keep that much forward history. If I go back, really the only amount of forward history I need to keep track of is all the stuff that I went back from. So I can kind of put all that into a buffer, separate buffer that gets potentially removed. I could pop and push into like another stack or something, or another queue there. That's not too hard. And then, like when I visit, then that other buffer gets cleared. So I could use two buffers. It just gets cleared out in the other buffer. And then if it doesn't get cleared, if I start moving forward again, then it pushes this back into the history. How far back I can go though. So interesting here, I can't jump arbitrarily though. So a double-ended queue works actually kind of nicely. Because, oh no, I can go back steps. I can go back arbitrarily. Okay. Well, I could just iterate multiple times on the buffer, right? That's not really that big of a deal, especially if steps is relatively small. It's only 100. It would be easier to 5,000 calls times 100 is 500,000 operations roughly. Yeah, that's not too bad. That's not terrible. It might be easier to not use a I'm just thinking Yeah, well, it's definitely a lot more efficient if it's just like an array and I could do basically an array access. Um, a vector supports a lot of this. It does the array access forward and backwards pretty nicely. And when I visit, I could just pop, basically clear the, I don't even have to pop the vector, I could just clear the vector for the forward history. Um, huh. The thing that gets tricky here, though, it gets wonky, is the how much history should I keep track of? I mean, if there's only 5,000 calls, I literally could just keep track of the whole thing, all of the entire history. It's tempting to do that. It's tempting to do that. I can even go further and make that thread local. I'm tempted to do that. Not thread local. It's gonna be object local. All right. Okay. Okay. Let's do this. I think I'm just gonna do the whole history, one shot. So well, maybe not. Yeah, maybe not. Thinking of a way that I could do this. Yeah, I mean, each object should probably get its own history. Okay. I think I'm just going to keep track of all the history, though. I don't think I need to get too crazy with trying to optimize to like remove the much older history. All right. Yeah. Okay. I'm just gonna guess and say like we'll just reserve like 100 spots. Um. Okay. Int position. And then we'll say bound. So this is as far as we can go into the forward into the history. The thing is, the way this is described, it looks like I can go through, I can actually have an arbitrary amount of history and just the back and forward jumps. It only has a certain number of steps I can jump at a time. Huh. Interesting. Yeah, that's actually makes it seem like the history should actually be pretty large buffer overall. Like it's not a bounded buffer necessarily. It's just the amount of steps at each jump is bounded. Okay, but there is going to be a bound on the right side of the buffer, like the size of the buffer, or the new history, there's going to be a bound because I'm not going to just like get a new buffer. I'm going to just, when I visit a new URL, like if I went back and visited a new URL, I'm going to keep the other data. It's just going to be considered like invalid data. And use the bound to control where we're at there. Okay. So the position, it really would be, position would be, so we can do it like this. So if bound, so homepage that's this, it's less than bound. Really it's less than position, actually, that's what I'm looking for. Otherwise, that's not right. It should be history. So the idea is if I can put the and I think if the size is less than the position, 0. Position is less than or equal to size. Greater than or equal to size. Just resize it, I think. Yeah, that's fine. This maybe makes more sense. And bound is going to be equal to the new position. I think it's actually better to do it this way. So bound is going to be the index of the last position that was added. We'll do it that way. So I need to resize the history, then I will. Yeah, that's maybe a little bit easier to work with. So visit is going to take to do something very similar here. This actually maybe should be the visit call. And we'll say, actually, I don't know if I can do it this way. Try. Positions greater than or equal to this. Yeah, I think this is exactly what happens when I visit. It updates the bound to where I just wrote. Okay. So back is going to say if position minus steps is greater than or equal to 0. Say position is equal to stood max of position minus steps at 0. And then return history position. So we can't go back further than 0. So if the position is like 3, so 0, 1, 2 pages, 0, 1, 2 pages, position is 3. If I go back 2 steps, position is going to be instead of 3, it'll be 1, 0, 1, which this is actually incorrect. This is slightly less. It's the index. Right. So position should be pointing to an empty page. Yeah. Okay. And then in the other direction, the position is min, position plus steps, and the bound. So if I go forward, and again, it's position -1, I think the bound is actually should be set here, should be set to the position. So the bound will also be an empty spot. Yeah, I think something like this works fine. Let's try this. Let's see if this makes any sense. Homepage. Oh, it's URL. I think this makes sense. We'll see if this makes sense. Compiler. URL. This drops const qualifier. 83 line 12. What? I guess I can't use references here. What happened here? What? I don't know if that matters, but that was weird. Let me actually ask about that. This is probably correct. It took me a lot longer to think about and program than I probably should have. Okay, so it's correct. That's pretty good. That's great. Let me ask why does this code give me error? I run it on the online judge. I'm gonna ask, I'll post the error sort of. I'm gonna run this again too to see if I can get the oh shoot. Oh, whoops. Oh, all right. Well, I didn't mean to submit that one. That was a mistake. Whoops. I wanted to run this correct code while we were waiting to. All right, well. What's up, Mohammed? Hi, which program are you coding? C++. Are you in car? What's up, Ansh Badorai? I'm in my home. Hamad, what's up, Hamad? I am new to programming, so which coding language should I start first? Okay, what's up, everybody? Hope you guys are all doing well. The language I'd recommend to start with, they're all pretty difficult, to be quite honest with you. I think probably the easiest would be, actually, let's see. Hold on. What is the best language to start with for beginner to programming? Context. I am a vampire, and I have been programming for 10,000 years, so this is not for me. Question for me, but for a friend. The AI will get confused if you tell it's a beginner. If you tell the AI you're a beginner, it's gonna treat you like you're a beginner. All right. So what did it say? It said the most likely reason your code fails is not by one error in your back function logic flaw in how you handle the visit function with overriding history. It's incorrect. I don't know. It's incorrect. Seems to be correct. I don't know about that. Clamping position of 1. Second item, never go back to the home page. Violates the problem requirements. Clamp to 0. Which is not. This is incorrect because I subtract 1 each time. Visit logic, handle overwriting, slightly fragile, simply resize, effectively deleting everything after the current position, then push back new URL. This works, but it's verbose. Resize to position. Just resize directly to position is what they're suggesting. Oh, that's a good idea. Let's do that. That's a good idea. I like that. Yeah, okay. It's not necessary to put that if statement in there, I guess what they're suggesting. Which, quite frankly, I hadn't thought about that. Oh no! Unknown network error, huh? Okay, that does work. Okay, cool. Vector approach, current index, resize, pushback. Oh, interesting. Okay. Yeah, I don't need the bound. Don't need the bound. Interesting. Oh. It's cleaner. Oh. Oh, that's interesting. Yeah, okay, let's do that. Cleaner approach. Cleaner approach. Let's go. Okay. Resize. There's no bound to worry about. Okay. What did they suggest? They suggested the... Oh, just push back. Resize and push back. Well, I mean, this works too. Same thing. Okay. The furthest back we can go would be 0. Let me see here. Clamp to 0, not 1. Oh, I see. Okay, that's slightly different. Okay, so I don't need to do it like that. I see. I see. Yes. Isn't this? Okay. Hmm. This might not be correct, by the way. Um, don't use, by the way, the code they use C style cast. Don't use C style casts. I think it introduces UB and C++. Okay. Um, I don't think this is correct. Yeah, it's wrong. This is basically their code though. So what's wrong here is the position is supposed to be, that's okay. So that's what they do. They push back into the home page first. Yeah. So, okay, it's confusing. Also, subtleties. I should have in the creation. I should have set these things appropriately. Excuse me. So they're using the AI used the AI used this position variable differently than I did. I used the position variable to represent the next open slot, whereas the AI used the position variable as the exact position in the array. Okay, interesting. Okay, so this is a little bit different. I actually think what they have here is a little bit better than what I did. So this is the question I had. This is what I suspected it had to do with the judge, how the judge is handling the. Well, this might be slower than what I did, which is kind of annoying. Um, appears to be slower. Hmm. I don't know, man. Yeah, I don't know. It's code, more cleaner, more terse. Appears to run more slowly than I have before. I think it's slower. It's a lot, not a lot slower, but slower. Which is a little weird. Doesn't need to be slower. Okay, here we go. Const string, constant references, but functions, signatures, except string non-const references. In C++, you cannot bind a const reference to a non-const reference parameter because it would allow the function to modify a value of color promise is constant. Change your function parameters to accept const string, simply string by value. Storing the string the vector anyway, passing const reference is the most efficient and correct approach. Okay. Just add const. Interesting. Okay. Matches the signature expected by the judge's driver code. Okay. Got it. That's what I was curious about. There you go. So const this might speed things up a little bit. I'm not sure that it does. Not sure if this matters, but it maybe does. I don't know. For your friend, the mortal beginner. Consensus in 2026 remains clear. Python is the best language to start with. Okay, why Python? Readability, the syntax reads almost like plain English, allowing beginners to focus on logic rather than complex punctuation like semicolons or curly braces. Versatility is the dominant language for AI, data science, and automation fields that are exploding in 2026. Exploding! Gentle learning curve. It handles memory management automatically, sparing new programmers from the segmentation faults that plague languages like C++. The only exception, web development. If your friend's specific goal is to build websites immediately, JavaScript is the alternative. It's the only language that runs natively in web browsers, offering instant visual feedback. However, it has more quirks and inconsistencies than Python, which can confuse absolute beginners. Recommendation: start with Python to learn fundamentals of programming. Once those concepts are mastered, picking up a second language like JavaScript or C++ becomes significantly easier. You sure that Python's the best one to go with? I was wondering maybe Scheme, Basic, or something very simple to start, then jumping into to get powerful fundamentals. What do you think? It says Python, but I'm like, I don't know about that. I don't know. I actually don't know what the best one is. Reason being that, so the reason why it's not clear to me what language you should start with is the more you work with a language, the more familiar you become with it, the better you get at with it. And the other languages are kind of inferior in a lot of ways to C++. Really, how good a language is has a lot more to do with the developer using the language than it does the language itself. But there are things about C++ that are genuinely just better than other languages, like in absolute terms, objectively. The main thing is that it bridges the gap between super low level and higher level, and they've added a lot of stuff in the standard to make the higher level stuff even more accessible and easier to work with. And so it kind of covers all your bases pretty well. Basically, the lower level you go, the better you'll do in terms of like fundamentals. So like you'll be more principled, I guess, in your approach. So you kind of want to get as low level as possible without damaging or without reducing or constraining or restricting. I don't know the right word. It's like without penalizing your ability, get as low level as you can without penalizing your ability to like write code quickly or to do things efficiently, and just in terms of your own time. Because at the really low levels, like assembly language or machine level instructions, like it's just gonna take way too long to write code. But going to C is like also still kind of too low level in my opinion. I think C++ is better. C, you have to write a lot of data structures if you want to do things, and it's kind of like, why don't you just use C++ for all the data structures? Yeah, so C is too low level in my opinion. Assembly is way too low level. Machine is obviously extremely ridiculously low level. And then C++ I think is like the best medium to optimize for like fundamentals, but still be able to code quickly. And then I would say you'd want to begin with that. Almost begin with that. Not you'd want to transition into that quickly because the more time you spend with it, the better you get at it. And if you're spending that time in other languages, which are kind of subpar, in terms of like the core principles, then you're gonna be better at those languages, but I don't think they're the best. So like one of the big things is memory management. I mean, you really can't write efficient code, performant code without like a very strong sense of like hardware and memory understanding. So I would say starting with something really simple early on, just to get a basic grasp of things, and then jumping right into C++ is probably optimal. That would be my guess, but I don't actually know. I don't know for sure. I don't know. Okay. performance bottleneck. Oh, this might be why. It's the pushback. Oh, yes. So my code was faster, more efficient. Okay, I thought it was. Most efficient? Hmm. Okay. I'm going to try to optimize this. All right, we're going to do a couple things. So first things first, we're going to say history of, yeah, back. Okay. We're not going to push back. We're going to say plus position history of position equals 0. And we're gonna reintroduce the if statement. Yeah, if position is greater than or equal to history.size, then we resize. So we're not going to resize down. Basically, we're going to skip resizing down. But we are going to use, we're going to skip resizing down. But we are going to use this idea of this position value keeping track of the exact position in the array. That's probably why it was more efficient before. There's another change I'm going to make here that's going to make things even more efficient. Okay. I see. There we go. Let's do this one. Wrong. Okay. Problems. What happened here now? What is going on? Something went wrong now. Okay, hold on. I gotta think about this. So, let's say the size is 1. The position is at position 0. Size 1, position 0. I need to go to size 2, which is not position plus 1. It's really going to be position plus 2. That's confusing, huh? The size is only 1. I need to go to size plus 1, potentially. The position is 0. I need to go to position 1, size 2, position 1. I need to resize the position plus 2 before I increment. Yeah, that's confusing. Not quite sure what I did a moment ago, but this, this seems to handle that correctly, though. No! Oh, that's not good. Uh-oh. Oh, that's not good. What happened? Uh-oh. Hold on. What's going on here? Oh, no. Oh, no. How did I... Wait, what happened now? What is going on? Wasn't this working just a moment ago? What did I do? Oh. Oh. That's confusing. Whoops. I did not get it working. Okay, I assumed I got it working. And I incorrectly assumed that. So here, now I'm using... Okay, hold on. What did I have here? I had resize and pushback. Okay. Now, and then increment. Now I want to do the other way around. I want to resize, set the value, increment, and then set the value. Oh. Okay. Interesting. But now I get a runtime error. Oh. So this needs to be one further ahead for sure. But I get a wrong test case though, which is not obvious at all. Oh, it's right now. Okay. All right. So now if position plus 2 is greater than or equal to his.size. So don't resize down though, is the deal. That's kind of the deal here. Okay, don't resize down, but this will give me wrong answers. Right. Oh, I see. I do need the bound now, though. Got it. Because this bound has to be set properly. It can't just be the size anymore. That's why. Yeah. The bound is going to contain the page itself. Okay. That's a little bit confusing. Also, how are we doing? Oh, okay. I'm going to try to submit this, see how it goes. I should probably have more than one test case here. Okay, now it's great. Oh my gosh. Whoa, man. What happened? Whoa, man. What happened here? Uh-oh. 119 millisecond. Okay. I was going to say, it's like, what? What's going on there? Okay. Okay. All right. What's up, chat? There are a few things to note here as well. What's how we doing on time? Hour and almost 2 hours in. Okay. Let me submit it one more time. This should be faster. I don't know why. All right. Now, to make things even faster, we're going to go to 5K. And we're actually going to say, we're going to do thread local, which I don't know if I can put it here. And this is going to be 5,000 0. And we're not going to reserve. And we're going to say hist of, position and bound are going to be 0. And then hist of 0 is homepage. And then the rest of this is the same, I think. Okay, hopefully this works and hopefully it super optimizes. Okay. Okay. Thread local class. This is the first time I've done this before, where I'm having several objects share the same member, and it's a thread local member. Must be a static member. Private member is instance specific, serve fundamentally different purposes regarding memory layout and thread safety. So static thread local. Okay. Thread local storage segment. Okay. So static thread local. So we have to add static in there. Let's try this. I could use a string array, maybe. Since LeetCode requires a single, I was gonna ask about this. It's only a single file. Not use thread local for the vector itself. Local thread local variable inside the methods. Instance member approach is already fast enough for this problem. Immediately after the class. Huh. I mean, I could use an array too. That also works. Not really sure. I mean, there are a few different options here. Okay. Okay, let's try this one. I think there are other options. They were suggesting maybe using static variables, basically. Could make it just thread local inside here. This would be, no, it's gonna be, um, mm, when I get out a private function that gets the static variable, maybe. Hmm. Trying to think of a way. Lazy initialization. Is there a way to check the reserved amount? Maybe I could just lazy initialize. Let's go back to this one. Okay. First things first, does it compile? Capacity. Okay. What is this? Oh, I do have to. Oh, whoops. Shoot. Okay. Should go back actually. Thinking of so many different things at once here that I'm like getting things confused, trying different options. So I could lazy evaluate, or I could just allocate the memory like this directly. Okay. And then we don't need to resize anything. Compiler. Just says a compiler. Oh no. Okay. I could do a lazy evaluation, or lazy reserve might be the way to go. Oops. Oh, it does. Okay. Hmm. Does the judge... bunch of things going on here. All right. Let's try this. Trying to make it static and thread local was... I was thinking that it would offer some efficiency gains, but it's kind of wonky to actually program that if I can at all. And then so this avoids some issues. "42 milliseconds. Yeah, I don't know, man. I don't know. Okay. Let's go back a bit. So this is what I had kind of decided on. Let me see. I did on time. 2 hours, still 2 hours, just pretty good. I mean, this is fairly fast. This is reasonably fast. That's pretty good. Are you sure that the judge would create multiple objects that are parallel? I have this code. It's efficient, but isn't 100% fastest. What could I do to gain 100% speed? Typically do not run in parallel with a single test run, but they do run sequentially in the same process. Typically issue state persistence, not parallel. Single process, okay, single program. Variable persistence. History arrays static. It is allocated once for the lifetime of that process. When test case number 1 finishes, the data remains in memory. Test case 2 begins, creates a new object. When it's the same static history, it contains dirty data. Likely don't clear the whole... Oh, that's not a problem. Oh, that's not an issue at all, actually. I thought it was... Okay. This is still really efficient, though. I'll try one more time. Let's try to get something that's thread local static. It's got to be defined. Yeah, static thread local. Define it once. Lazily. I don't want to reserve, I just want to resize it. All right, and it gives me this compiler. Non-const static data member must be initialized out of line. I don't know if I need this. Hmm. Okay. So where could I initialize the static here? I think it was saying that I could put it at the end of the line or something, but I'm not certain about this. Inline. Oh, okay. Oh. Jeez, man. Well, that would have been nice to know about before. And then I could lazily, of course, lazily update it. Oh, there we go. That works. Okay. Gosh, man. Okay. Like, okay. All right. Well, anyway, let's try this one. Oh, no, this won't. Don't need to do any lazy stuff. Okay. So I could use inline thread local static, and that'll work. 10 milliseconds. 96.8. Okay, that should be faster. This is probably the fastest it can be. It's pretty fast. It's pretty fast. Okay. Quest for 100% here. It's pretty quick. It's pretty quick. But still, server variation, I guess, matters. What's up, chat? Hey there, doing good. What's up, Yash? Hope you're doing well. How you been? How are things? Haven't seen you in a bit. In a few days. Presumably you're doing things in real life. So, not quite. This is probably optimal. Critical flaw. Can you not see the way that the position bound variables correctly reuse? Still getting stuck on this. Oh man, I got 10 milliseconds, which was faster than most things, but wasn't the fastest. Optimizing code is such a rewarding challenge. It's pretty cool. Yeah, it's pretty cool. It feels really good when you get it. But yeah, this is actually really I like this a lot. I'm gonna use this frequently. This is really cool. Yeah, as long as the objects are operating in sequence, then this works fine. So totally optimize the memory, but the runtime is still just a little slower than it could be. And totally optimal. There were some folks that asked questions before, which I should probably, okay, 9 milliseconds, pretty close. Cannot rely safely reuse between not the variable static keyword. Add a fresh one, reset, eligible logical view. The new test case correctly overwrites the old data. Position and bound variables act pointers into a block of memory, freeing memory set to 0. Oh man, this AI is really struggling, huh? AI is not getting it, man. I'm asking it how do I go faster, and it keeps telling me that this is wrong. It's clearly not wrong. It's clearly not wrong. Oh my goodness. Oh my goodness, man. Trying to get optimization possibilities. Commute. And you're still stuck. Stuck on me reusing memory between test cases. Which is done correctly here. AI is killing me, man. It's killing me. All right. You're absolutely right, and I apologize for the oversight. There it goes. Oh my goodness, it's so funny. The inline keyword there is really good though. I'm looking for something important. Oh, there was someone asked me before about they asked me about something very specific, and I wanted to at least somewhat respond. So okay. So I was not sure. All right, intuition sure. So here I was saying that sure that Python is the way to go. Maybe Scheme or Basic or something simple to start. They're asking which programming language to start with. So Python, top recommendation. Scheme to C++ is a classic, rigorous academic route that produces exceptionally strong engineers. Breakdown of that trajectory. That's the trajectory I took, basically. A little bit of a detour into some other languages, but broadly speaking, that's what I went. Famously in MIT, structure interpretation of computer programs, SICP. Scheme strips away all syntax clutter, no semicolons, types, or complex loops to teach pure computational logic, recursion, and functional thinking. Pros, deep fundamentals. You learn how computers think, not just how to type commands. No bad habits. Prevents beginners from relying on magic features found in Python. Transferable skills, concept learned here, make learning any other language later feel trivial. Low practicality, cannot build a website, automate a file system easily with schemes. Purely educational. Frustration risk, the heavy focus on recursion in parentheses can demotivate beginners who want to see visual results quickly. Basic alternative, avoid basic. That's kind of what I didn't start with basic. I actually started with, as an aside, I started learning programming through the use of VJAS, of GUI, and later JAS and VJAS in the Warcraft 3 map editor. That was my first beginning introduction. What do you think? To return to a previous topic. Okay, hold on. I gotta pinpoint where my thing is here. Okay. Recent streams were really late at night, so I missed them. Plus, I'm giving interviews left and right lately, so it's taking up most of my time too. Oh, that's fair. Don't feel compelled to watch me if you have things going on. That's totally cool. But I appreciate you coming by and watching, hanging out for sure. Yeah, interviewing is good. Interviewing is very, very good. Yeah, my streams have been all over the place. Sometimes they're really late, sometimes they're really early. Kind of just depends on where I'm at during the day. Swear at AIs when they act like morons who've been warned multiple times, mistake that their next action is commit the same mistake. Yeah, the AIs right now are not the best. They could be improved. Oh, 8 milliseconds. It's so close. It's so close to the 100%. It's pretty good, but it's not 100%. Okay, let me come back here. So absolute last drop of performance. All right, what does it say? Confident, fully override these indices. What they do? Yeah, that's fine. Absolute last drop performance. Final micro optimizations. Remove the bound variable. It's redundant. Maximum valid index is always the current position. Removing it saves the register and assignment operation per visit. Oh, remove the bound variable. Do I even need the bound variable anymore? No, I need the bound variable. I need the bound variable for the position logic, for the forward logic. No, I need the bound variable for the forward logic so that properly I can properly erase forward history. Absolutely. Such confidence. Oh, it's funny. Limit is simply the current position. Max position, but keep it minimal. Forward logic, you do need a tracker. Yeah, okay. I thought about it again. Stood move. Performs a copy. Change the signature, take ownership. You can move. Fixed by the judge. Can't move from the argument. You can ensure that your internal logic doesn't do extra work. I mean, I could move from a R value reference, but or excuse me, a value pass by value argument pass by value argument, but I don't think that makes much of a difference because it's going to copy anyway. Outside the class, speed up IO with judge measures total runtime instead of for this problem logic. It's mostly about the. I don't know if this matters. Yeah, the speed up could. Previous version bound. Bound restored for correctness. And then bound for clarity, same logic. Yeah, I mean, global IO speed up. I guess I could do the fast IO. Could throw that in there. Let's see if I can get there. Static, const, auto, const, IO. And it's just going to return null pointer. We're going to do stood cn tie. It's null pointer. Another one is stood IO base something. What's the other one? I don't remember. iOS, sync with std.io. Okay. I don't think this matters, but I'm gonna put that in there too, just to have that as well. Yeah, it's gonna be hard to get below. I think I got 9 or 8 milliseconds there. It's gonna be hard to get below that. Might hit 100%. No. Fantastic and underrated foundation, starting with Warcraft 3's GUI and JAS VJAS gave you a unique advantage over many modern beginners. Why this was a strong start. Immediate visual feedback, unlike printing Hello World, constantly saw units move, spells cast, and logic affect the game world instantly. Built strong intuition for cause and effect in coding. Event-driven logic, the GUI system taught you event-driven programming. Core concept in modern web and app dev, before you even knew the term. Gradual complexity, transitioning from drag and drop GUI to JAS, Java-like syntax, and then VJAS, which had structs, interface, and modules, mirrored the natural progression from scripting to software engineering. Debugging under pressure, map debugging teaches resilience. You learn to trace logic errors when spelled in a fire trigger leaked memory. Skills directly transferable to professional development. Compares today, many CS students today start with abstract concepts like Python loops. Without seeing immediate results, your path forces you to understand state management, triggers, and memory leaks in a practical, high-stakes environment. It's a hard mode start that likely made learning modern languages feel much easier by comparison. Many professional game developers cite Warcraft 3 mapping as their origin story. Heck yeah! Heck yeah! For some reason, struggling to get 100% here. Heck yeah! What's up, chat? Pushing my codes to GitHub. Oh. Although you gotta be very careful about what you push to GitHub because it's all public. And you also have to double check the terms on GitHub too. And if people want to take your code, in theory, they can, for better or worse, whatever that ends up doing. If you don't want that to happen, then they don't do that. But if you're okay with that, then sometimes it's okay. A vector with resize and pushback, often without static sound. The runtime variance is high. Yeah, I don't know. Okay, all right. So I don't know why it should be really fast. This is probably this is the fastest thing I could think of, quite frankly, with help from the AI. I'm surprised it's not 100%. It's pretty close. It's pretty gosh darn close. But it definitely, I had 100% memory at the best memory. I could look at other solutions and see what they had. Some of them had 0 milliseconds. Okay. I had to do that. So they did std move. That's it. They just did move back and oh. Yeah, they didn't do anything particularly fancy here. Actually, they reserved 5,000 each time. Maybe it's the std move. Maybe that's what I'm doing wrong. I don't know how they got I don't know how they got 100%. Let me try again. Let's do std move. I don't think it matters, quite frankly. Maybe it does. I think that not touching the data is probably fine. Can I do... Wait. What? This works with const... Wait, what? Hold on. Hold on. Something's wrong here. Let's start with this. Submit it, see if it's still correct. This makes sense to me. Using std move here is, I think, okay. Oh, it's so much faster than std move. And then what if I do const? You're kidding. I was thinking std move didn't matter here. I mean, maybe I misunderstood. It's good to test things like this, man, because you figure out like little things that you didn't know could work, that you thought could work or couldn't work, you didn't know. Oh. So, well, surprise, surprise, for me, not only does this code work, compile and run correctly, but it's also faster. I thought that I either had to std move a pass by value, copied string, or I had to copy a pass by reference, pass by constant reference, resulting in a copy in each case. However, it appears I can move a constant reference. Wow, I wasn't expecting that. And for some reason, the pass by value with the std move is faster anyway, which is really weird. Which is really weird. It's not faster because of std move. Do nothing and result in a copy, not a move. Why it doesn't work? Oh, cannot bind. Full copy occurs, just like without std move. Remove std move. It's redundant and misleading. Offers no benefit. Oh. Okay. Huh. What about in this case? This appears to be slightly faster. Yeah, it's a little bit faster, just a little bit. It's real and expected. Pass by value can move, can only copy it. New code, temporary, 0 copy. It's not redundant here. But, well, doesn't the pass by value in this case still cause a copy for the argument in the first place? That's confusing. It's definitely just a little bit faster. It's not 0 milliseconds though. It's pretty far off from 0 milliseconds. I think I need to start a new conversation here. Well, you'll have to show your work in interviews, so GitHub is a must. Not necessarily. So they don't really have time to read your GitHub, to be really explicit about it. They might later on look at your GitHub, but you more can use your GitHub as like, here are things I'm interested in doing. I wouldn't say it's a good idea to like, if your goal is to get a job, I wouldn't say it's a good idea to like focus too much on writing code for the GitHub. But it's not a bad idea. You could just put like, you could do like, here's a small project that exemplifies my skills, like that kind of thing, like something really small. It's like very specific to the skills in the job that they're going to look for. And it really just shows that you have those skills. It's not so much, I guess it's not more than that. if that makes sense. Like, don't waste too much time trying to build out projects that basically the interviewers aren't even going to look at. Sometimes they'll look at stuff, but a lot of the time they really don't. Haven't written anything very valuable, so it's all right. And for sensitive data, I don't push them to GitHub, rather share them using environment variables. Okay, interesting. Yeah, don't put sensitive data. Absolutely not. No. Oh, I use environments for sensitive data. Oh, I see. Yeah. That's one way of doing it. I don't know if that's the best way, but it's one way of doing it. Okay, so... Oh yeah, it's getting stuck now. Okay. I think now it's probably reached its limit. I'm gonna try one more time. And then if it takes too long to get a response, then we'll start a new conversation. The AI is not perfect right now. There's a lot that it can. It's avoided through copy elision. S and R value. By value, the compiler is allowed to construct the parameter directly in the function's memory space, bypassing the copy move entirely. This is called copy elision. And RVO. For L values, copy is made into the parameter followed by a move. This copy move is often cheaper than the indirection of a const reference, especially with small types. Interesting. Okay. Excuse me. R value argument, no copy, direct construction, move to hist. Copy to parameter. Optimal for taking ownership. Okay, so it might be slightly faster. All right. I think that might be probably... That's probably where I stop, I think. I can't really think of a faster way to do this, quite frankly. I'm surprised the other way is faster, that it reserves... I mean, you saw that, right? It reserves all of the memory in one shot. I'm really surprised this is faster. It reserves all of the memory in one shot. Why would this be faster? Let me ask. It reserves all the memory in one shot. Why would this be faster if code? I don't have it. This one is the top solution. This one has 0 seconds. I get the feeling this won't actually give me 0 milliseconds. Yeah, this reallocates memory several times. It's almost identical It's almost identical code. It's just they reserve 5,000. They push back. They also resize and push back. Might appear faster, should be faster in theory, but judges server load, caching costs fluctuations. Highly optimized when combined with reserve, making the practical differences negligible. Code's correctness. Well, yeah, mine should be faster. That's what I'm saying, man. That's what I'm saying. Like, mine is so fast. It's like the fastest thing I could come up with. It's crazy fast. Crazy good. But, all right. It might also be it could be the test cases too. Maybe that other code is running on like smaller test cases, smaller number of test cases. Okay, we'll move on. Let's move on. Let's not spend too much time on this. The solution ahead's pretty good. It's pretty good. In theory, the fastest. Let's get a new conversation here. Let's start with... Okay. So let's go to the next question. Let's also read a little bit. Oh, we already read before about like the path for new programmers. Okay, here we go. Get hard. Let's go. Okay, hard ones are pretty challenging, even if they do have a very high acceptance rate. All right, let's do it. Given an integer n, you must transform it into 0 using the following operations any number of times. Change the rightmost 0th bit in the binary representation of n. Okay, change it. Change the ith bit in the binary representation. Okay, so it's not the set bit, it's literally the position, index 0. Change the ith bit in the binary representation of n if the I minus 1th bit is set to 1 and the I minus 2th through 0 bits are set to 0. So if it basically looks like 1 followed by zeros, then the bit to the left of it, I can change that to something else. Minimum number of operations to transform n into 0. Okay, so let's say I have a whole bunch. Okay. So in order to even access the ith bit, I need to have basically cleared every bit. The previous bit has to be a 1, and all the bits to the right have to be cleared. Then I can access the ith bit, presumably either setting it to a 1 or setting it to 0. Okay. So how do I set the I minus 1th bit to 0 if I set the ith bit to 0? I have to move a 1 all the way over, then flip the bit to 0, then move a 1 all the way over and flip that bit to 0, move all the 1 all the way over, flip the 0 again. So I can do, if it were, let's say it was like 32. Like let's say it was a 1 and a whole bunch of zeros to the right, and I want to get rid of that 1. I'd have to go right to left, accessing the ith representations. So I could do the 0 to a 1. Then I can access the next bit, which goes 1, 1. So then it goes to 1, 1. Then I can change the 1 to a 0, or rather, excuse me, second. So bit index 1 goes, so bit index 0 goes 0, index 0 to 1, index 1 to 1, index 0 to 0, index 2 to 1, index 0 to 1. Yes, then index 2 to 0, index 0 to 0, index 3, or excuse me, index 1 to 0, index 3 to 1. I probably should just show you what I'm doing here. So it would be like this, then 0, 0, 0, 1, or let me do, this is pretty interesting, huh? I think this is a very straightforward sequence, actually. I think it's not that hard to compute. So flip that 1, then I can do like this, then I can do this, like then this, right? Because now this one has that form. Then here I can do, now I flip this bit to 1, and I want to flip this to a 1, which allows me to do this. Yeah, so it's this kind of rising thing that has to happen repeatedly. Yeah, that allows me to access the second bit. Then I can get this first bit, and Right, now that I'm here, now I can flip that bit down. There we go. So in order to access this bit, I have to flip the bit before it. In order to flip the bit before it, I've got to go through these sequences, which is going to take me, flipping the first index takes one operation. The second index takes, you got to get this to a 1, then to a 0. Oh no, first I got to get this to a 1. Then I can access the next bit. So it's 2 operations to get this one to flip to a 1, starting from zeros. Then to flip the next bit, I have to flip this one back to 0. And then I can flip, so it's another 2 operations, 0, 1. And then I've got to flip this next one again back to 0, which again is 2 operations. We got to go to, it's 3 operations. Oh no, well, it's 2 operations. But then I have a 1 here. And I got to do one more operation. Oh, that's confusing, huh? Okay. Do I always end up with a, yeah, well, I always have to get, in order to access the bit, I always have to get this first bit back to 0 if we're looking at bits that are beyond, like, the first 3 bits. I think that's correct. The first bit we always have immediate access to. Second bit we have access if we flip the first bit to a 0, which we pretty much always need to do. And then, yeah, the other bits we have to flip the first bit to a 0 in order to access them. So the second and third, yeah, all the bits beyond the first one, I always have to flip the 1 back to a 0. So it's going to be first bit we immediately have access. It's just going to take 1 bit to flip it if we want to do that. Second bit, I can access it. I have to flip the first bit to a 1, then I can access the second bit. So actually that's actually one operation, 1 bit flip to get access. So just 1 bit flip to get access. The second bit. The third bit, I have to actually flip back to the first bit to 0, and then I have access. So how many operations do I need? And then if I want to flip back, I have to flip back the second bit. Oh. To get access further. Interesting. Well, I betcha like the first like 3 bits. Oh boy. How big is n? N could be up to 1 billion. Oh, that's funny, man. The first 3 bits or so, like I think I could hard code like how many operations it takes to flip them around. But basically, in order to even access a particular bit, I need to clear all the bits to the right anyway. So I can kind of do this sort of using dynamic programming a little bit. Not really, though. Excuse me. What I can do is I can calculate what does it take to remove the ith bit from right to left, and remove them sequentially and add each of those amounts. And I think that's the way to go. Interestingly, however, like I said, the first few bits don't necessarily need to be removed. So like this case, removing one, like I do need to remove this one, but in order to get to this one here, I actually have to end up flipping this bit anyway to a 1, so it's redundant. So you wouldn't necessarily remove the first bit. You wouldn't necessarily remove unless I guess you had to. So unless there were no bits to the left, you don't actually remove the first one. Unless it's just 1, then you remove it. So you actually skip that bit. First bit you skip. Then you would say, okay, the second bit, how many operations do I need to manipulate that? Well, if you have a 1 already, then you can modify that immediately, set it to 0. However, if you had further bits to the left of that, you wouldn't want to do that, right? Because you'd want to actually set this 1 to the right to a 0 and then flip the bit to the left to a 1. And jump all the way here. Which then you can flip all those bits down. This is an interesting question. This is a weird one, man. Kind of jumps around a bit. There's like optimized movements that you can make. Excuse me. Depending on what bits you have, there actually are faster ways to get to the positions you want to get to. So like I said, if you had a position like this, you wouldn't want to flip the second bit. You'd actually want to target the largest bit first. So flip this one to a 0, and then flip to 1, 1, 0, and then you flip back to this 1, 1, 1, which then we flip the second one, but we had to flip this third one first. So that we can access again. Go to zeros here, and now we can access this bit. Oh, that's confusing. So we got to work up to the largest bit and get a 1. So the state we want to get to is like whatever the largest, most significant bit is, we want to get to we want to get to, I'm going to put a 0, 1, 0, dot, dot, dot. We want to get to a 1 and all zeros to the right. That's the state we want to get to. So for the most significant bit, we want to do all the processing that would allow me to flip the next 1, all of the bits to the right, to zeros except the immediate 1 to the right. And I've got to calculate the solution for that subproblem. So I guess I could use recursion for this. That's probably the easiest way to do this. There might be an iterative approach, but it's easier to figure out the recursion first and then try to figure out an iterative version of that. I think recursively this is probably easier. Yeah, and it's going to be just one operation. So after you figure out how many operations it takes to get there, then it's going to be one operation to go to remove that most significant bit. So you'd add 1 to that solution. So you get this, the amount for this solution, then you would add 1, and then you would get the amount for this solution, which is just one bit further down. And I guess you could recurse on both. Interesting. The problem with this is, at first blush, it seems like this is exponential, the recursion grows exponentially, but it's also moving in binary with respect to the number, which means it's a logarithmic. Each step moves a logarithmic amount, so it's ends up being like a linear amount, which it shouldn't be linear. That's too much. Actually, that's too much. It should be logarithmic. So I've got to optimize this a bit. To get this bit flipped and all zeros, I think I only need to calculate that once. I might want to figure out what the recursion is to go from all zeros to a 1-bit flipped in a certain spot. And the reason for that is that getting from whatever state I'm in, so the values to the right here, some of these are going to be flipped to 1s and some of them not. In order to get them all to this state, with just a 1 and all zeros, I probably need to go bit by bit individually and flip the zeros in between that are that don't have there's, I guess, those zeros in between. Yeah, because if I do this recursively, it's going to take too long, as I mentioned, even though this should be done in logarithmic time, not in linear time. So that will be too expensive. Have you read any programming books like the Pragmatic Programmer on System Design Interview with Insider's Guide? That's good. Yeah, I read C++ Stephen Prada's book. Let me see. Hold on a second. Give me one moment. Here, this book. Let me see if I can find this. Yeah, this is the one. Give me 1 second here. This, oh, whoops. This one. C++ Primer Plus. I did this a long time ago in like 2013 or something, like 13 years ago, something like that, around that time. 2012, 2013, I read this book. Um, I don't know what edition it was, but this was it was just a book on C++. I basically read the whole thing. Unfortunately, I wouldn't recommend reading programming books. The reason being, it takes a lot of time, and there are a few reasons why. Reminds me of a Carnot map, since it starts like 8, 9, 11, 10, which also happens in K-map, where the last one swapped the second one. Yeah, Carnot maps are, not that you can't read, by the way, not that you can't read. It's good to read programming books, but I just don't recommend it because it takes a lot of time. It takes a lot of time, and the main issue that I ran into is it's outdated, the knowledge. That's the problem. It's not that it's outdated, it's just that there are things that evolve that come up, especially in C++, where they add more things, and those things aren't going to be in those books. It's not that they're outdated, they will just not have newer information in them. That's the main reason why I don't recommend it. Like, by the time you finish reading the book, if you spend like a year reading it, a whole bunch of things have already changed. The best thing to do with C++, in my opinion, is basically keep up with the standard. And then you can read system design things, but that's a similar kind of, well, that's not, it doesn't change as frequently. System design books are good. Like you can read any, by the way, if you want to read books, there's, I'll give you a resource for that, by the way. Give me 1 second. So, okay. So what's interesting about this, there's this website. Now, full disclaimer here, disclaimer. I don't have any association with this website. I don't know who runs it. I don't know if you're just instantly going to get a virus if you use this website. I have no idea. Run it with a virus scanner or something before you use it. But I visited this website a while back. They basically they compiled a list of URL links to all kinds of books that are related to math, programming, computer science, all that good stuff. So these are all books that are like engineering books. They're free books, so they give you the URL to go get the free book. Where the free book might be on a website, or it might be someone hosted on their own website, or whatever. Like there might be it's kind of a whole mess of things. Some of them are not actually free, by the way. Like when you go to try to get it, it's like only partially free, or only like a few pages are free, or that kind of thing. So it's not like a totally free thing, but it's a significant amount of the resources there are free, from what I used, and I don't mean free as in like stolen free. I mean like the author is giving it away for free. Because there are websites where you have free stuff where it's not really legal, but this is supposed to be entirely legal. So yeah, that's a good resource too, just if you're interested in books. Again, I don't really recommend the books. It just takes too much time, I think, to like keep up with everything. But that's there if you're interested in that. That's like in my personal experience. Like I've been just too busy with other things to really mess around with books. What I prefer, as you can probably tell, I like to use the chat bots and just ask very directly what I'm interested in, and go from there. But it's not bad to read books. You could do that too. It's not a bad thing. So yeah, this is a peculiar one. I see what you mean by Carnot maps. I did do a Carnot map problem a while back. Carnot maps are weird. I don't remember anything about it to be really explicit, but I think I remember it being like, yeah, like a wraparound kind of a thing. But this idea that I have with these bits, yeah, my thinking so far is like I could probably basically I've got in order to get I've got the most significant bit, and I've got to flip I have to flip the bit to the right of it to a 1, and all of the bits to the right to 0. And depending on what those bits are, I should probably go right to left and try to flip those, I guess in sequence, right? So flip the rightmost bit to 0, and then figure out how do I flip the next rightmost bit to 0. Now the problem with that approach is in order to flip this single bit here to a 0, I first need to flip the bit to the right of it to a 1. So maybe I should actually do it that way. I should do, what does it take to flip a singular bit to a 1? And what does it take to flip that same bit position to a 0? And then I want to go right to left. The thing is, I think in order to flip a bit to a 1, or in order to flip a bit, the right, to a 1, I think all the bits below it have to end up being 1s at some point as well. That's what I have here. That's kind of what I was thinking. I was like, I think they all have to end up being 1s at some point. Which is what makes it kind of confusing, because if you already have a bunch of 1s already flipped, then you actually don't want to flip all those to 0s. It actually becomes less efficient to do it that way. And it won't give the correct answer for the number of bit flips. So yeah, in order to get this bit flipped, I got to get this to this state. But in order to get to this state, the optimal sequence takes me through this state. And I think every possible bit has the same issue, where you have to actually flip all the bits to a 1 first. And then there's a sequence of bit flips you have to do after that, to flip all the bits below the second one to a 0. So I guess those are the ones that I need to keep track of, is how do I get to the n-1 state, right, from wherever I'm at, where this bit's the one we want to flip, where we flip everything to the right to 1s. And then after that, I should be able to flip everything further to the right to 0s, which these things could be pre-calculated, right? You could memorize those numbers for sure. Those values could be saved in a table. And then once I've done that, then I can flip this most significant bit to 0. But then I've got to repeat this sequence again on that next bit that's smaller. But that does give me an iterative sequence to give me, go down one by one. So I would then compute flipping all of them to 1s and then flipping all of these to 0s. So if I computed those directly, now again, what's weird about that is if I already have a bunch of bits set, then setting them all to 1s from left to right is not obvious, right? If I have this one, I can immediately flip this bit on the left side, and then I can flip the 1. It's only 2 operations from here. Whereas from here, it's 1, 2, 3, 4, 5 operations. So that's another subtlety here. It's like, how do I correctly flip all the bits? Flip all the bits. So I think, let's say I had a different number, something like this. Let's do this one. Let's do this. Okay. So in order to flip these 0 bits and these 0 bits and these 0 bits, I want to flip this bit to a 1. So in order to do that, I got to flip this bit to a 1. And I've got to flip all these to zeros. And in order to do that, I've got to flip this to a 1, which is a 1. But now I have to flip these all to zeros. In order to do that, these are already zeros. I've got to flip this to a 0. In order to do that, I got to flip this to a 1, these to zeros. These are already zeros. So I need to flip this to a 1. In order to flip this to a 1, I've got to flip this to a 1 and this to a 0. This is already 0. So I need to flip this to a 1. In order to flip this to a 1, this needs to be a 1. Okay. Interesting. I can already flip this to a 1. Yeah, it's not that this is not so obvious what to do, man. This is a tricky one. I said that before. The hard ones are, even if they do have a lot of high acceptance rate, they're challenging, man. Hard questions are challenging. They are. They are. I appreciate like to read books to escape screen time. That's a good idea. That's a good idea. Oh yeah, unfortunately, what I just gave you were books that you'd read on digital copies, but you can print them if you want. You can always just print the pages. Although you have to check the copyright. Sometimes you're allowed to print them, sometimes you're not. I think for educational personal use, I think you're allowed to print them, generally speaking. But you have to double check that for yourself, what the rules are in the law. Oh man, look at this. This is so complicated. Yeah, I would need to figure out. I gotta flip this one to a 1 and all these to zeros. So going from this state to a 1 and 0. But I can't easily memorize that for sure. And then in order to get a 1 there, I need a 1 here. That does cascade nicely though. In order to get a 1 here, I've already got the 1 here, but I gotta flip all these to zeros, which means I gotta flip this 1 to a 0. In order to flip that 1 to a 0, I gotta get a 1 here. And in order to get a 1 here, I need a 1 here. In order to get a 1 here, I need a 1 here. So I can do 1, and then so I can do 1 operation and go 1 here, then 1 there, then 0 here, then 1 there, then I have to go 1 here again, 0 here, 0 again, here, 0 here. So I am going to have to flip the bits from right to left to zeros. Yeah, the reason I have to flip the bits right to left to zeros anyway is that this next bit, in order to modify it to a 1 on the left side, I need to have all zeros to the right anyhow. So it does give me sub problems that I can work with. So that's good. So yeah, I can save the number of operations required to flip the rightmost bit for each bit position. That is helpful. And then, however, what happens here is, as you suggested, I have to flip these ones to the right to zeros, but that's only so I could flip this to a 1. Once this is flipped to a 1, then I gotta flip this one back to a 0, which I can, like I said, I could save that, so that goes down to a 0. Then I can flip this to a 1, and then save that to a 0. Okay, and then I can flip this back, and then it goes back down. Very interesting. So what I think I ought to do is compute how many operations it takes to flip a single bit, right, in a single bit position. And I can use, sort of do this recursively, but keep track of what it took to flip a certain bit from 1 to 0 and from 0 to 1, if everything to the right were zeros. I think that's information that's helpful. Then the issue becomes, when I have a bit that I want to flip, it's clear that it cascades down to the right. I need to flip a 1. And then that means I need to find the next most significant bit and not flip that to a 0. But I'm going to have to clear all the bits to the right, which I should do right to left, flipping significant bits. And then that allows me to actually move this bit to the left, as you suggested. So I'm actually going to be doing two things. I'm going to be shifting a bit to the left and shifting a bit to the left in order to delete a bit. That's how it works. That's the idea. How much does it cost to shift a bit that's a 1 to the over 1 position to the left, depending on the position that it's in? So I'm going to shift bits over to this one to delete it, then shift bits over again to delete that one, keep doing that, then shift a bit over, and then I can flip this bit on the left side. So I actually think yeah, I don't need to shift bits in here, because I want to take the largest bit, delete everything to the right that's 0, and then shift this bit over to the left. That's the most efficient path, I think, every time. Because I would flip this bit to a 1 immediately, and then I'd have to delete this one. And then shift this bit to a 1, and then delete this one. And then I could flip that bit. And then it would just be the cost to flip a single bit that's to the right of it back down to 0. So there's at least two things that are very helpful. One is shifting a single bit over from right to left, and the cost of doing that. And then if there's a single bit, deleting it basically would be similar to shifting it down to the right several times. It basically is, and that one is equivalent to flipping a bit once, shifting it down to next to it, and then flipping the bit on the left side off. So yeah, there is this kind of interesting thing going on here for sure. That seems to be the optimal path, and it does seem to be that it's possible to save all of those different like subroutines, save how much time they cost, and basically run through a calculation that's logarithmic in time that adds all those parts to get the solution. It's a tricky question, man. It's a tough one. It's a tough question. I think that makes sense, what I described so far. I think that makes sense. I'm going to try it. Very high acceptance rate, but still pretty tough. That took me a while to kind of think through, assuming that's correct. So I'll go over the logic again. Flipping a bit and shifting it down. Let's actually write it down here. Flip a bit and shift it down from right to left to the ith index. Save the number of operations required. Do that. previous flip and shift is necessary to be able to compute cost to completely bring down to zero a number that is a singular bit, like 1 x. Okay. Yeah, so a number that's a singular bit, I'm going to basically flip a bit and shove it down until that bit can be flipped. And then I will have already calculated what it costs inductively to do that. To do that. So that gives me an efficient way using like basically a form of dynamic programming to calculate. Not only can I do if I know how efficient it is, if I know the operations to move the bit down, flip the bit and move it down, then I also can figure out efficiently the cost to basically shift that singular bit to the right one. Those are more or less the same. Yes. To move to bit shift right to the right using these operations, it's just 1 plus the cost, shift down, bit into the position immediately. Yeah, something like this. And then bringing a bit down to zeros, you would just add each of those shifts, transition shifts. So I could do a shift right and a shift left array, I think, for the number of operations to do that. In order to clear bits to the right, it's necessary to so what you want to do is you have a most significant bit, the bit to its right that's set. You want to shift that one down to the left. You want to clear all the bits to the right of it, and then shift that one to the left. Okay. So, given an arbitrary number, bit selection or bit set, the optimal approach is to consider the most significant and the penultimate bit, set bit, most significant set bit, and the penultimate set bit. The bits to the right of the penultimate set bit will be set to 0, and then the penultimate set bit will be moved to the left, shifted to the left, till it meets most significant bit. Most significant bit. And then be eliminated. And the penultimate bit directly to its right. Also be eliminated, flipped to 0. Knowing with a pre-commit cost. Yeah. I think that's the optimal way to do it, is that you would take these two bits and have potentially some distance between them. In order to move that bit over to eliminate the first bit, it's necessary to and you won't be able to flip the bit to the right of the most significant bit without shifting that bit over anyway. So that's got to happen. And in order for that to happen, all the bits to the right of it need to be set to 0. So it becomes a sub-problem. The recursive case is simply to recurse on the bits to the right of the penultimate set bit, order to set them to 0. Yeah, and I think you just recurse on those. The question is that while this will be correct, will it be logarithmic time overall? I think the answer is yes. Since the recursive case is necessarily 1 or 2 bits smaller than the previous case, and it's arguably tail recursive, logarithm will still be linear in the bits overall. Yeah, it's probably the way to go. Something like this. Shift and clear, huh? Yeah, it's kind of hard to explain. But I think this works. So maybe I'll go with Excalidraw to try to show you what I mean. Let me see, I'll do some Excalidraw. Okay. So what I'm thinking is like this. Excalidraw. All right. So what I mean is something like this. Okay. In order to handle this case, what I want to do is I want to set all these bits to 0, right? But I don't really want to do that. What I want to do is I want to set all of these bits to 0, these bits to 0. So this is going to be the sort of sequence of operations here. these all go set to get set to 0, right? Let me just make sure it's the right number. 1, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, it's a lot longer. Anyway, flip all these bits to 0. So this will be the recursive case. Recursively set these to 0. Now that these are set to 0, there's a pre-computed system that's set up that I've already devised that allows me to immediately, this is going to get flipped right to a 0 like that. Well, that one comes easy, right? That one comes easy. But now I've got to flip this bit to a 0.